Yo, what's up guys? In the last video I announced that I'm going to be coding chess in Minecraft. Today I'm going to be talking about how I'm going to code the legal paths of the pieces. And I'm going to be focusing on the bishop and the rook, which are the hardest to code. Now what makes these two pieces difficult to code is that they can move infinitely in a certain direction until they hit the edge of the board. So how am I going to actually calculate their movement? Well, let's start with the rook. The rook is very simple. It only moves horizontally and vertically. And what this means is that one of the coordinates, either the x coordinate or the y coordinate, is going to be exactly the same. So all I have to do is compare the x coordinates and the y coordinates, and if one of them is the same, then that means that it is a legal move. The bishops are a little different. They can move diagonally in any direction. So how can I calculate whether a move is legal for the bishops? Well, if you notice, whenever the bishop moves, each coordinate is changed by the same amount. For example, if I change the x-coordinate by 2, notice the y-coordinate has to change by 2, whether through addition or subtraction. So what this means is that the change in the x and the y coordinates has to be equal. So by obtaining the change in the x-coordinate and the change in the y-coordinate, and then taking the absolute value of each, in other words, ignoring the negative sign, those two values should be equal. And so then this way I can actually create an algorithm for checking if a bishop move is legal. Now let's talk about how the computer is going to deal with any obstructions in the path. Well, what I first want to do is figure out which general direction the piece is moving in. For the rook, it's pretty simple. If the x-coordinate is positive, if the change in the x is positive, it's moving to the right. If the change in the x is negative, it's moving to the left. Same thing for the y. If the change is positive, it's going up. If the change is negative, it's going down. The bishop is fairly similar, but you have to think about the movements like quadrants. So if the change in the x and the y are both positive, it's going up and to the right. If the change is both negative, it's going down and to the left. Now, because every single square has a correlating value, once I figure out which direction it's going in, I can assign a number to increment it by to move one square in any direction. So if I want to move down and to the left, I have to subtract 9. If I want to move just straight down, I need to subtract 8. If I want to move down and to the right, I need to subtract 7. All the way up to if I want to move up and to the right, I need to add 9. So now I can continuously increment the starting point by this value, and I can basically scan its path. And if I run into a piece before I get to its desired new location, I can say that move is not legal because it is blocked. I'd say that these two, the rook and the bishop, are the hardest to code because they can move really infinitely in any direction. There's not really any set location that they move to. So I showed you guys some clever ways to simplify the process of 1, finding out if it's a legal move, and 2, finding any obstructions in the path, other pieces. Next video I'll probably cover the easier pieces like the rook, the king, and the pawn. And don't worry if I haven't mentioned the queen, because all the queen really is just a mix of the rook moves and the bishop moves. So I can really just treat each queen like a combination of a bishop and a rook. So stay tuned for that video, and peace.